Here's the spreadsheet we developed for question 5 in Unit 19. Question 6 asks us to calculate again with a slightly more reasonable assumption about the chances of our dying in each year. Back in question 5, we assumed that there was the same chance that we would die at any age from 90 to 40. In real life, of course, it's more likely that we'll die when we're older than when we're younger. So in question 6, what we'd like to do is have a percentage chance of dying at age 40, and then let the chance of dying at age 41 be higher, 10% higher. And then have the chance of dying at age 42 be 10% higher than that, and so on. Suppose, for example, that our chance of dying at age 40 was 1%. This is an arbitrary number. In that case, our chance of dying at age 41 would be, according to our assumption, 10% higher. Here we've added 10% onto the 1% to get 1.1%. If we continue this way, we would have the chance of dying in each year. But we run into a problem. It's perfectly reasonable to say that we have a 2% chance of dying at 48. But it makes no sense at all to say that we have a 106% chance of dying at 89. You can't have more than a 100% chance of dying in any particular year. So our 1% guess down here was too high. Suppose we put in instead just, say, 0.2%. All of the percentages now look pretty reasonable. But we still run into trouble when we add them up. Let's add all the percentages in this column. We'll start with 0%, and in each row, add on one of the percentage values. We'll reformat this so it doesn't take up so much space. Here's the 23.48. We add on the 21.34. And this gives us a 44.8% chance of dying in one of these 2 years. There's a 64% chance that we die in one of the last 3 years. And here we run into trouble. We have more than a 100% chance of dying in one of these years. That can't be right either. In fact, there must be exactly a 100% chance of our dying in one of these years. The percentages in this column should add up to 100%, but they don't. They add up to 256%. Let's fix the problem using goal-seek. We'd like this value here to be 100%, and we'll get it by changing this value down here. There. Now we have a starting value that, if it increases 10% each year, gives a chance of dying in each year, so that our total chance of dying in one of the years, from 40 up to 90, is 100%. Now we've fulfilled the requirements of the problem, and as it turns out, there's nothing left to do. These values here are the value of $100,000 paid off at various points in time. That doesn't change. Our formulas take this percentage, whatever number it may be, of this value to calculate the fraction of the present value that we really expect to get. And this column starts at 0 and adds up all of those values. The policy might be worth $87.20 or $100,000 or anything in between. But what we've calculated here is its average value, which is $15,937.90. This is the answer to the question, and notice that it's much lower than the answer we got when we answered the previous question. That makes sense. With our more realistic assumption, it's more likely that the money will get paid out later when it's worth less. So the average value is lower.